So in this video we are going to discuss about something about superconductors and the concept of superconductivity. Now you know, in this age of technology and everything, the conductors are also because we have some or the other resistance in the conductor. So that is the reason why the superconductor concept has come, and the companies have developed these things. Now when we speak about superconductivity, so it is a phenomena of zero electrical resistance. Okay, now because of resistance, conductors pose different problems. There are losses in the conductors. So that is the reason why superconductor concept came and developed, and that is a phenomena of zero electrical resistance and expulsion of magnetic field occurring in certain materials when cooled below a characteristic critical temperature. Now, electrical resistivity of a metallic conductor decreases gradually as temperature is lowered. In ordinary conductors such as copper or silver, this decrease is limited by impurities and other defects. Now this decrease is limited by impurities and other defects. Even near absolute zero, a normal conductor shows some resistance. In a superconductor, the resistance drops abruptly to zero. The resistance is dropping abruptly to zero when the material is cooled below its critical temperature. Now, an electrical conductor with no resistive heating can carry current any distance with no losses, giving it essentially 100% efficiency. Once direct current is introduced in a superconducting loop, it can flow undiminished forever. In superconducting material, the characteristic of superconductivity appears when the temperature T is lowered below a critical temperature, that is Tc. Now we are denoting the critical temperature Tc, and then we are denoting the temperature as T. Now the value of this critical temperature varies from material to material. Conventional superconductors usually have critical temperature ranging from around 20 K to less than 1 K. Solid mercury, for example, has a critical temperature of 4.2 K. Many metals and metal alloys have been found to be superconductors at temperature below 23.2 K. These became known as low temperature superconductors, that is LTS materials. So that those are LTS material. Extensive research worldwide has uncovered many oxide based superconductors with potential manufacturability benefits and critical temperature as high as 135 K. A superconducting material with a critical temperature above 23.2 K is known as high temperature superconductor. So they are known as high temperature superconductors. So which has a critical temperature above 23.2 K. Okay, please remember it. Now we'll just read this. An American superconductor has taken a major step towards forward constructing a prototype 5 megawatt 6667 HP high torque AC synchronous STS motor that is designed to suit the needs of ship both for in hull and podded propulsion system. In podded propulsion system, this motor has been demonstrated successfully at full load under steady state operational condition. Okay, so this motor they have developed. Now what is the advantage of this STS motor is that they are extremely compact, measuring a little as one third the weight and half the size of copper based motors of the same power and torque rating, which means navy ships can carry more fuel and ammunitions, sorry the spelling is wrong, and have more rooms for the crew's quarters and weapon system. Okay, so in especially in naval ships, that is now their efficiency and highly to have lower maintenance cost, so they will have lower maintenance cost as well, sorry. And the STS motor being developed by these major changes in fundamental motor technology. So they did this major fundamental change. The machines operated in the same manner as conventional motor, gaining their substantial advantage by replacing copper rotor coil with STS rotor coil. Now we have copper rotor coil, wherein we have this copper losses also in the motor. If you see this hysteresis curve, now here we have STS rotor coil. The rotors of STS motor run cold, so they avoid the thermal stresses experienced by conventional machines during normal operation. 5 megawatt STS propulsion motor rotates at 230 rpm and generates 2 lakh nanometer of torque at full load. no, 20 lakh, okay, sorry, no, 2 lakh nanometer of torque at full load. This is a subscale version of 36.5 megawatt, 49,000 HP, 120 rpm, 2.9 mega newton meter STS motor, being specifically designed to provide propulsion power for the next generation of warships. Okay, now this Queen Elizabeth II, wherein you have this motor. Now another marine application for high temperature superconductor being developed by Siemens. Siemens also developed, one was the American, then another we have a Siemens, is current limiter to protect against short circuit. Siemens I&S has developed a current limiter based on STS technology to protect ship power supply systems. Short circuit current are automatically limited to a non-critical value as soon as the current rises, owing to the sudden increase in the inherent resistance of the superconductor. After a current limitations, even the operability of the STS current limiter is self restored in a very short time. The service life of the electrical system is consequently prolonged and its reliability is enhanced. So its reliability will be enhanced. Now when we speak about advantage, then it has a wide range of advantage. uh, Current density 100 times greater than that in the conventional copper winding. So STS winding carry current 100 times more than what we have with the copper winding, as a result of which significant weight and volume reductions are possible. In addition, there are no electrical losses with STS, so that means greater efficiency. So there is no electrical losses, so there is a significant weight reduction. So the warships that we speak about, so they can carry more ammunitions and fuels, okay, and the hysteresis loss, sorry, this losses are less, because the rotor is carrying 100 times more current than your copper. The enclosed self-regulating system, which cools the superconducting rotor windings of the motor to a temperature of 27 K, promises cheaper cooling with low maintenance. STS motors therefore create totally new flexibility in ship design and the layout of the system on board. As a result, it is possible to design more energy efficient ships with more effective capacity utilization that have less environmental impact and are cheaper to operate. Electrically propelled ships are inherently quieter than their diesel counterparts, and the superconductors reduce vibrations and engine noise even further. Now, commercial applications of superconductors: electric power generators, transformers, underground cables, synchronous conductors, fault current limiters, industrial motors, magnetic energy storage. Transportation: ship propulsion system, magnetically levitated trains, railway traction transformer, electric vehicles. In medicine, magnetic resonance imaging, that is MRI, particle beam therapy, industry, magnetic separators, large motors. Communication: STS filters for cellular communication systems. Scientific research: accelerator magnets. Now see, superconducting electric machines are electromechanical systems that rely on the use of one or more superconducting element. Now since superconductors have no DC resistance, they typically have greater efficiency. The most important parameters that is of utmost interest in superconducting machine is the generation of a very high magnetic field that is not possible in a conventional machine. This leads to a substantial decrease in the motor volume, which means a great increase in the power density. However, since superconductors only have zero resistance under a certain superconducting transition temperature, TC, that is hundreds of degrees lower than room temperature, cryogenics are required. So it is only functional at this cryogenic temperature. So that is the catch here. Cryogenic is the, what is cryogenic? Cryogenic is the study of production of very low temperature below minus 150 degrees centigrade, minus 238. Now the LNG ships, you know that they are more into this cryogenic. Now because there we are maintaining minus 161 degree Celsius. Now Meissner effect. The Meissner effect is an expulsion of magnetic field from a superconductor during the transition of the superconducting state. Okay, now Meissner effect is an expulsion of magnetic field from a superconductor during its transition to the superconducting state. So that is the we are expulsing the magnetic field. Diagram of the Meissner effect. Magnetic effect lines represented as arrows. This you see, this is that, and excluded from the superconductor when it is below its critical temperature. Okay, so I hope this is clear for you. I have tried to compile this material from different sources, and in a nutshell, so that is the reason why we just go through it. Okay, my idea is not to teach you, my idea is to bring the content under one umbrella. Those are self-explanatory and the surveyor expected answers. That is important to know. So I hope it is clear for you. You can pause the video and you can just read it, because we take notes from different sources, different websites, study materials, reference books. Thank you so much. Thank you for your valuable time. All the very best for your future endeavors.